Okay, we have here another problem from the Berkeley Math Tournament 2022 Calculus Tiebreaker number 1. We have the limit as n's going to infinity of the integral from 1 to n of natural log x over n ln n dx. Okay, it's always a little bit scary when we're mixing the limit with the integral. I think for my first step here, just focusing on the integral's with respect to x, and we've got some stuff here that's all in n. So this part here is a constant that can come out front of the integral. So rewriting it still all within the limit, we're going to have this constant in front, 1 over n ln n, and then this integral just becomes ln x. Then from here, I guess we have a couple of options. We could bring this constant into the denominator, and then we could use L'Hopital's rule, because then we're going to have a fraction where both pieces are going to infinity. Yeah, the integral, because the integral is clearly going to diverge when it's going to infinity here. Another way we could do it is I think we could just integrate this right here. So I can do this with a formula. The integral of natural log x is going to be x ln x minus x, and we're evaluating from 1 to n. Plug in n, we get n ln n minus n. Then we plug in 1. Here, let's be clear with it. So we're going to be subtracting. It becomes 1 ln 1 minus 1. But ln at 1 is 0. Minus times minus is plus. So this whole thing is going to be 1. Let me rearrange it a little bit. We'll do 1 minus n plus n ln n. Then I can take this value and we can throw it back into the limit and see if we can finish it off. Now here, with it broken up in a fraction like this, I'm thinking we could actually just break this up on the minus and plus and do it as 3 limits. Each one I think we can evaluate separately. So we can write this as limit as n's going to infinity of 1 over n ln n minus limit of the second one, which is just going to be n over all this stuff. And the last one, here I'm running out of space. Let me see if I can sneak this in. It's just going to be n ln n over n ln n. But then this one here, this is clearly going to 1 because we can just cancel everything, and then we're just evaluating 1. So this piece is 1. Here the n's cancel. We have 1 over this, but this is clearly going off to infinity. So this piece is going to be 0. This piece is clearly going off to infinity. ln going to infinity is still infinity, so this piece is going to 0. And so all we're left with is this. So for my final solution, we just get 1, and that's it. Again, L'Hopital's rule is a pretty good way here. Take the derivative on this fundamental theorem of calculus, and it comes out about the same way. So, and that was probably just as quick. I don't know. It's both pretty quick. So anyway, okay, that's it for today. Thanks everyone for watching. Have a good day.